Let's call this angle A, B, C. This is side A, side B, side C. Now the law of cosines, you can rewrite that 3 times. You can say A squared equals B squared plus C squared minus 2 times B times C times cosine the angle between B and C. What is the angle between B and C? Which angle? Angle A. Or, if you want to use that side, B squared, it's equal to, that's this side, it's equal to this one squared plus that one squared. And it's always minus 2 times the product of these two times cosine the angle between A and C. Or this angle, whatever that angle is. So if this is A, the angle is going to be A. If this is B, the angle is going to be B. And if you want to write in terms of C, that's this side, you can say C squared equals A squared plus B squared minus 2AB cosine angle C. Okay, let's take an example. Let's take the one that we tried on the previous video 2 minutes ago. That didn't work out. That was this one. We tried the law of sine, we could not do it. So let's try the law of cosine. So let me draw that one we have here. This is what we had. This was 110. I'm copying this example from 2 minutes ago. This is 6. That's A, because this is angle A. This is angle B. C. This is B. C equals 7, side C. We said the law of sine will not work here. So let's try the law of cosine. If I can find one of those sides, once I find one of the sides or one of the angles, I should be able to finish it with the law of sine. I don't have to stay always with the law of cosine. I don't like the law of cosine. It's too much work. Look at them. A lot of work. Maybe I'll put them together. So let me see if I can find side B. Well, if you want to find side B, I'm going to use that equation. B squared equals A is what? 6? That's 6 squared. C is 7. 7 squared minus 2 times A, which is 6, C, which is 7, times cosine angle B, which is 110 degrees. B squared equals 36 plus 49 minus, what's that number? Let's see what that number is. 2 times 6 times 7 times cosine 110 degrees. That's a negative 28.7. Minus a minus will make it a plus. +36 plus 49 plus 28.7. It's 113.7. And what is B equal to? The square root of 113.7. And that's 10.7. So once I have that, I don't have to use the law of cosine. It's too much work for me. So maybe I'll go to the law of sine now. I can mix and match. As I said, I'm not a fan of the law of cosine. Too many steps in it. So the law of sine now says, wait a minute, you want to find angle A or angle C? A over sine of A equals B over sine of B, which equals C over sine of C. Do I know what A is? 6. Sine A is unknown. Do I know what B is? Yes, I just solved for it using the law of cosine. 10.7 over what? Cosine 110. How many unknowns in that alone so far? Isn't there one unknown? I should be able to solve for sine A. Cross multiply. Six times cosine 110 equals 10.7. What did I say cosine? That's a sine, right? Six times sine 110 equals 10.7 times sine of A. To solve for sine of A, we divide by 10.7. So here we go. Six times sine 10 divided by 10.7. Which is 0.527. Can we get angle A? There are really two answers to that question. Let's see if one makes sense or not. The inverse sine. I get 31.8 degrees. Remember, when you have the sine equals a number, there are two answers to that. You flip the paper along what? So this is the 31.8. If you fold that paper along the y-axis, you have another angle right here. And that angle will be how big? 180 minus 31.8. Which is 148.2. But that doesn't make any sense here. Why? Because we already know one angle is 110. All the angles, when you add them, is 180. So if you make angle A equals 148.2, you're already over 180. So that doesn't make any sense. So this is 31.8. Now I know what angle C is. It's 180 minus 31.8 minus 110. (180) minus 31.8 minus 110, which is 38.2. So I mix and match actually the law of sine with the law of cosine. You will see me try to avoid the law of cosines as often as I can. The same thing, if you were given three sides, you'll have a problem there too. Let's try another one. I come up with a story here to use to make it more attractive there. Okay. Let's take this example. There's an airplane flying. An airplane is talking to a tower. Here's the tower here. To the ground. This is the tower. An airplane is talking to that tower, and the tower knows that aircraft is, 2.4 miles away from him. That distance. The tower is also talking to another aircraft a little bit higher than the one. We're not going to make them collide here. That aircraft is what? Let's say the height of that is 3.6 miles. If you're the person in the tower here, you can find the angle between the two aircraft. And let's say the angle between them was 132 degrees. And the question, how far are these aircraft from each other? What is that distance? So I'm looking for that distance from this aircraft to that aircraft. What's that distance? That could be an application for the law of cosine. Notice you are given two sides and the angle between them. Immediately you know the law of sine is not going to work. That you'll be wasting your time. So you want to go to the law of cosine. So here's my triangle. Let's make it a little bit cleaner. You can label it any way you want to. You can go A, B, C. This is 132. This is 3.6. This is 4. And you are looking for side C. That's the side that's opposite. This is side B. This is side A. I'm looking for C. The law of cosines says C squared equals A squared plus B squared, just like before, but now you're going to subtract from it 2 times A times B times cosine C. Okay. So let's look at what is C? Unknown. C squared equals, what's A? 3.6 squared. What's B? 2.4 squared minus 2 times A. A is what? 3.6. B is 2.4 cosine angle C, which is 132. .6 squared is 12.96. 2.4 squared, 5.76, minus, this number will be a negative number, 2 times 3.6 times 2.4 times cosine 132. That's negative 11.56. So let's add the minus a minus here. That'll make it a plus. So here we go, 12.96 plus 5.76 minus that number, and you got C squared equals what? 30.28. And to get C, we take the square root of that number. I pushed the wrong button. I got syntax error. 30.28, the square root of that. And it's 5.5 miles away from each other. So they are too close to each other. 5.5 miles, nothing in space when you go in 400 or 500 miles an hour. When you go in 500 miles an hour commercial plane, that's just one plane. There's two planes. It's only going to take you what? You can travel almost 8 miles every hour. So every minute. 5.5 is like 40 seconds for one plane moving. If both of them moving, we're talking about 20 seconds between them. Boom, you see the airplane going at each other. There's not much time between them in case they come at each other. Because if this is going 500 miles per hour, this is going 400 miles per hour. You move at a speed of 900 miles per hour. 900 divided by 60, that's how many miles every minute? You cover 15 miles every minute. 15 miles. If you're only 5.5 miles away, that's a third of 15. That's 20 seconds. The pilots have 20 seconds to spot each other. If I don't see each other, you could be colliding this. You better see them and get out of the way. Let's try another one. An example. I know summertime people like to go swimming. There's a pool here, there's the water, and you're standing here, you look and you see a quarter on the bottom of that pool. This is the pool like this. The quarter is sitting right there. We know the distance from the person looking at it to that, let's say it's 5 meters. But if you know anything about water, just like in mirror, you got your mirror on the side of your car, there's right next to it, there's engraving, it says what? Object appear closer than what they are. Well, the same thing, when you're looking actually at an object in the pool there, it doesn't look like that deep. That quarter, instead of being here, is going to show up like being here. So to that observer there, it's 4.25 meters away, it looks like. Instead of 5. Now, what happens when you put like a pen in a glass of water and you look at it, or a pencil? What does it look like? It looks like it's bent. That's reflection. Let's say the angle of reflection, which is usually small because you're going from water here, air to water, it's about 8 degrees. Can you find like where that quarter is showing up? It's not on the bottom of the pool. It's actually showing up this high above that bottom of the pool. And what is that height? Notice what do you have? You have two sides and the angle between them. Again, the law of sine is not going to work here. So the law of cosine will have to be the way to do it. So this is what I'm looking at. This is the height. I'm enlarging the picture so we get to see it. We got this one, which is 5. We got this one, which is what? 4.25. We got this angle 8 degrees, and we're looking for that side. A, B, C. This is side A. This is side B. And this is side C. I'm looking for which side? Side A. The law of cosine says what? A squared equals B squared plus C squared minus 2 times B times C times cosine angle A. They're having fun outside. So A squared equals B is 5 squared, that's C is 4.25 squared, 2 times B, C, cosine 8 degrees. 25 4.25 squared, 18.0625 minus 2 times 5 times 4.25 times cosine 8 degrees. 42 here. 0.864. That's plenty here. $25 plus 18.0625 minus 42.0864. It's 0.9761. It's the square root of that number. .989. So actually that coin, it looks like it's 1 meter above the bottom of the pool. So if the pool is 3 meters deep, it looks like it's only 2 meters deep. And that's when a lot of people actually drown. They look, they see a rock in the bottom. Oh, it doesn't look like that deep. Because to them what they see actually, they see the coin sitting right there. They think the depth of the pool is now that distance. Instead of being 3 meters, now it's only 2 meters. Oh, I can handle that. Okay. So that's really what the law of cosine. It's used when you are given two sides and the angle between them. Because because the law of sine doesn't work, or you are given 3 sides or 3 angles. If that's the case, use the law of cosine. Otherwise, use the law of sine, much easier.